Hello and welcome back to class. In this lecture, I am going to define seismic parameters as per IS 1893. Now, click on load and definition. Go to the seismic definition, left click on add and select Indian standard IS 1893. Now, let's go to the seismic zone map of India as per IS 1893. You can see here Vijayawada lies in yellow color. Yellow color represents the zone 3. Now left click on generate and you can either select zone 3 and it is having a zone factor of 0.16, or you can just select city and go to the city Vijayawada in this drop down. So both the procedure are same. Select response reduction factor as SMRF. By default its value is 5 and the important factor for this building is 1. Select this geotechnical properties. Select soil type as medium and structure type as RC framed building. Damping ratio by default it is 5% and click on generate. We also need to calculate period along X and Z direction. As this is the frame with brick infill, so we can calculate time period with the formula TA is equal to 0.09 H divided by under root D. I will show you this formula in IS 1893. Our building lies in this category, so we will use this formula for calculating the time period. Here H is the height of building and D is the base dimension of building along the given direction. Now coming into this Word file, this is just a simple Word file for time period calculation. Measure our height of building, that is 16.5, and the base dimension along X is 11.360 and along Z is 15.520. So along X it is base dimension is 11.37, so we will get 0.365 as the time period, and along Z we will get as 0.376. I will enter this value in Staad Pro. Enter time period along Z X as 0.365 and along Z as 0.376. Left click on add, assign a self load factor of 1, click on add and just close it. I request you to read IS 1893 carefully if you are designing structure as per Indian standard in the seismic prone region. This was just a simple explanation of seismic definition. Alright. In the previous section, we have already learned how we can define the seismic definition. Now, in this lecture, we will move into load case detail. Left click on this load case detail, left click on add. Now you will see this primarily. First of all, if we are doing seismic analysis of any structure, then first of all we need to enter seismic load case in the Staad Pro. Select loading type as seismic and enter earthquake load along X direction, that is ELX. Click on add. Again enter earthquake load along negative X. Add earthquake load along Z. Earthquake load along negative Z. Now I am gonna select dead load, enter here DL, click on add, again select live load and enter LL, click on add. Now I am going to close it. So at first define self weight factor as -1, left click on add and close it. Let's assign this self weight factor to the whole view. After that we can define live load also, but we have already defined the seismic definition. So left click on ELX and left click on add. We can select, go to the seismic load, we can select direction as X and factor as 1, click on add, close it, again select EL minus X, select seismic load and enter factor as -1 in this case. Similarly, repeat the procedure for earthquake load along Z and negative Z. Select Z direction here and click on add, close it. Enter factor as -1, left click on add and close it. One last thing I would like to add here is, when we are defining earthquake load along X and earthquake load along Z, we do need to go to editor file and we do need to enter the perform analysis and change command. So let's go to the editor file here. Go down. After this load case first, that is after ELX, add syntax, that is perform analysis followed by change, and copy all this to all the 4 seismic load case and paste it. Now close this editor file and enter yes. If we do not enter that command, then it will show an error if this UVC analysis has tension or compression. So to avoid that error, we need to enter perform analysis and change command in the editor file. With this, see you in next video.